Bismillahirrahmanirrahim. Now we're going to continue our examples of dynamics integration of vector function. We have an example. A car starts its motion in a straight line from a constant point in the line where v equals 4t minus 3t square meter per second. Find through time interval from 0 to 4 v average vector and v average. Okay, as we know, v average vector equals delta displacement over delta t, and we have delta t here equals 4 second. Okay, then we need to find delta s. Delta s equals s minus s naught. By definite integration we can find delta s, definite integration from 0 to 4 v dt. Okay, then we have integration from 0 to 4t minus 3t square dt, and this integration equals to t square minus t power 3 from 0 to 4. The limits of this definite integration, direction of c, and c is unit vector in the direction of motion. Then ds equals, we substitute by 4, then subtract substitution by 0. You have 4 power 2 minus 4 power 3 minus 0 equals negative 32 in direction of c. Okay, then by substitution here, v average vector equals delta s over delta t. Then we have negative 8 direction of c meter per second, and this is required in first point. Okay, to find v average equals here x, okay, or x or delta x. X is the distance traveled or covered by the body during time interval from 0 to 4 over delta t. Okay, also I have delta t equals 4 seconds, and we need to find delta x or distance. Okay, distance x is positive value over the entire path of motion of this cars. And we have first to find when the motion direction changed, okay, during the time interval 0 to 4. Okay, by putting velocity equals 0 first. Okay, then we have 4t minus 3t square equals 0. Okay, then we have t 4 minus 3t equals 0. Then motion direction changes, t equals 0 or t equals 4 over 3 second. Okay, then to find the distance covered by the body during these two in time intervals from 0 to 4.4 over 3, then from 4 over 3 to 4 second. Okay, we have to substitute in x equals, here we have integral from 0 to 4 over 3 v dt, okay, plus modulus also integral from 4 over 3 to 4 second, okay, v dt. Okay, you have to be sure that this instant or moment when the motion direction changes included in the time interval under study. Okay, then we have here x equals, by integration we have here 2t square minus t power 3, okay, from 0 to 4.3 second, plus okay, also 2t square minus t power 3 from 4 over 3 and 4. Okay, then by substitution, substitute first by upper limit, then subtract substitution by this lower limit in each of these two modulus. Then we from first modulus we will find here we have 96 minus 64 over 27, okay, plus negative 32 minus 32 over 27. Okay, then x covered by this body during time interval from 0 to 4 is 34.374 meter. Then to find v average you have to divide this 34.7374 over 4 time interval to find 8.59 meter per second, and this is required to find. We have another example. A car moves in a straight line with initial velocity 12 meter per second from a position distant 4 meter from a constant point. If acceleration equals x minus 4, find number 1 v square in terms of x, v when acceleration equals 0. Okay, here by using a definite integration we have half v square minus v node square equals integral of a dx x0 to x. Okay, then we have here half v square minus v node square equals 144 as v node equals 12 meter per second. This is equals integration from x node is 4 meter from this reference points, and we have x node is 4, and we have here x a is x minus 4 dx. Okay, then we have half v square minus 144 equals half x square minus 4x, and we have to substitute by these limits. Okay, here we have this equals substitution by x, then we have half x square minus 4x, then minus substitution of 4, we have here 8 minus 1 6, then here we have half x square minus 4x plus 8. Okay, this is equals half v square minus 144. Okay, then we have v square minus 144 equals x square minus 8x plus 16. Okay, then v square equals x square minus 8x plus 160. Okay, and this is required first. Okay, number two, it's required to find velocity when acceleration equals 0. Okay, we have acceleration equals x minus 4, this equals 0, then displacement at this point equals 4. By substitution here, then v square equals 16 minus 32 plus 160, this is equals 144. Then velocity here when acceleration equals 0 equals positive negative 12 meter per second or units, then this is required to find. We have another example. A particle moves in a straight line with initial velocity 2 meters per second from a constant point on the line. If acceleration equals e power x, find number 1 v square in terms of x, number 2 velocity when x equals 4 meters, number 3 x when v equals 20 meters per second. Okay, here we have a as a function of x, and it's required to find v square. Then we can use definite integral. We have half v square minus v node square equals integral from x node to x a dx. Then we have half v square minus v node square, okay, equals integral x here is from constant points, and we have x node equals 0 to x ex dx. Okay, then here by executing this definite integration, we have here e bar x, and we have to substitute from 0 to x. Then we have here half v square minus v node square equals e bar x minus e bar 0. Then we have e bar x minus 1. Okay, then v square minus v node square equals 2 times ex minus 1. Then v square equals 2 e bar x minus 1 plus v node square. We have v node equals 2 meter per second, then v node square equals 4, then v square equals 2 times e bar x minus 1 plus 4, and this is required first. Number 2, it's required to find velocity when x equals 4 meter. Here we have v square at x equals 4. You have 2 e bar 4 minus 1 plus 4, and this is equals 10 by 0.55 meter per second. Okay, number 3 is required to find x when v equals 20 meter per second. Okay, here we have v square equals 2 e power x minus 1 plus 4. Then it's required to find x when v equals 20, then we have 20 square here. Then here e power x equals 400 minus 4 over 2 plus 1. Then we have e power x equals 199. Then x equals ln 199. Then x equals 5.293 meter, and this is required. We have another example in this figure. The figure represents the relation between acceleration and displacement of a body moves in a straight line with initial velocity 8 meter per second. It's required to find velocity at x equals 30 meter and x equals 60 meter. Okay, then we have here a relation between a and displacement, and it's required to find velocity. Then we can use definite integration. Half v square minus v naught square equals integral from x naught to x1 a dx. Okay, then we have half v square minus v naught square equals, this quantity is the area under this curve over the displacement from 0 to 30. Then we have here area of the area under okay the curve when x equals 0 to x equals 30 meter. Okay, then this area is the area of trapezium, this trapezium. Okay, and it's positive of course as the curve is above x-axis. Then area of trapezium is half base 1, here base 1 is 10 plus base 2, this one is 30 times height is 6. Okay, then we have here this equals 1 to 0. Then half v square minus v naught square equals 1 to 0. Okay, then v square minus v naught square equals 240. Okay, here we have v naught equals 8 meter per second, it's given. Then v square equals 240 plus here 64. Then v square equals 304. Then velocity equals 4.19 meter per second when x equals 30 meter. Okay, we repeat when x equals 60 meter. Okay, then we have here two areas, the area of this trapezium drawn above the x-axis and this one under the x-axis. Then this area is positive, this area is negative. Then we have here the same definite integral, have v square minus v naught square equals integral from 0 to 60 a dx. Then here we have, this is summation of area 1 minus area 2. Okay, here area 2 of this trapezium drawn under the x-axis. Then we have here this equals area of first trapezium is 120 from step number 1, and we have here minus area of this lower trapezium half. We have first base equals 30, second base is 1 5, height is 3. Okay, then we have here 120 minus 135 over 2. Then this quantity equals 105 over 2. Okay, then we have here half v square minus v naught square, okay, equals 1505 over 2. Then we have v square minus vo square equals 105. v naught square equals 64. Then we have v square equals 105 plus 64. Then we have here 169. Then v at x equals 60 equals 13 meter per second, and this is required to find. Here you have to remember that the area of trapezium equals half base upper base plus lower base times the height. Here upper base is this distance is 10 meter, lower base is from 0 to 30, then we have 30, and height is 6. For this one we have upper, if we assume this one is upper base is from 35 to 50, then we have 15 meter, and we have lower base from 30 to 60, then we have 30 meter, and height is 3, and area is negative as the trapezium is below x-axis, and this one is positive. Then we have to add a1 minus a2 for second requirement to find the velocity at x equals 60 meter. We have another example. A particle moves along x-axis. Its position varies with time according to the relation r equals negative 4t plus 2t square meter. Find number 1 displacement during interval from 0 to 1 and from 1 to 3. Number 2, average velocity vector over each time interval. Instantaneous velocity at t equals 2.5 second, v average over 0 to 3 time interval, and v average vector over 0 to 3 time interval. First, if we roughly sketch the relation between r and t, okay, or from displacement and t as displacement equals r of t minus r of 0, okay. R of 0 is 0, then x equals r equals negative 4t plus 2t squared. Then we have displacement equals negative 4t plus 2t squared. If we sketch the relation between x displacement and time, we'll find this curve, okay, from 0 to 1 and from 1 to 3 we have two different time intervals, okay. First, it's required to find displacement x over 0 to 1, then displacement x equals, here we have negative 4t plus 2t squared, okay, from 0 to 1, then x equals negative 4 plus t plus 2, okay, minus 0, then we have negative 2 meter, okay, this is x over the time interval from 1 to 3, then we have x equals negative 4t plus 2t squared from 1 to 3, then we have x equals here negative 4 times 3 plus 2 times 9, okay, this is minus negative 4 plus 2, okay, then we have here here we have 8 meter, okay. This is first requirement. Number 2, it's required to find average velocity vector over this time interval from 0 to 1 and from 1 to 3, okay. Average velocity vector, v average vector equals delta s over delta t, okay. For first time interval we have delta s equals negative 2, okay, over time interval from 0 to 1 we have 1 second, then we have negative 2 meter per second. Average for second time interval we have delta s also over delta t, then we have here 8 over from 1 to 3 we have here 2 second, then 2, then we have 4 meter per second, and this is second required. Here we can check the curve as we have displacement time curve, since the slope of this curve at any point during any time interval represents the velocity of the motion during this time interval. Here from 0 to 1 we have the slope is negative, okay, as it makes an obtuse angle with positive direction to x-axis. Then we have here velocity is negative, here negative 2 meter per second from 0 to 1 time interval. From 1 to 3 the tangent here, the slope of the tangent is positive as it makes an acute angle with the positive direction with the x-axis. Then the velocity during time interval from 1 to 3 is positive, and this is clear here. Here we have positive meter per second during time interval 1 to 3 as the velocity vector. For point number 3, it's required to find velocity, instantaneous velocity at v equals 2.5 second. We have here displacement equals negative 4t plus 2t squared. We have velocity equals dx dt. Then we have negative 4 plus 4t. T equals 2.5 second, okay, by direct substitution. Then we have v equals 6 meter per second, and this is required in point number 3, okay. It's required to find average velocity over v average over time interval from 0 to 3 seconds, okay. Here we have to find first displacement, first distance moved by the body during this time interval, okay. Then to find this distance we have to find first when the motion direction changed at v equals 0, okay. Here we have v equals negative 4 plus 4t, and this is equal 0 at t equals 1, and this is clear here from this curve, as here the slope of this curve representing the velocity was negative during 0 to 1, okay, this time interval as the slope is negative. Then from 1 to 3 the slope is positive, then velocity is positive. Then the motion direction changed at t equals 1 second, as it's clear from this equation. Then we have to find displacement x equals modulus integral from 0 to 1, okay, v dt, or we can use direct x, okay, here, plus from 1 to 3 v dt, okay. We can use also direct equation given for x, okay. Then we have here we can find here, for example, x from 0 to 1 plus x from 1 to 3. Then we have here x, we have x minus 4t plus 2t square, okay, from 0 to 1 plus minus 4t plus 2t square from 1 to 3. Then we have here negative 4 plus 2, okay, minus 0, this is the first bracket, plus and this is modulus. Here we have to multiply negative 12 plus 18, okay, minus, by substitution of 1 here, negative 4 plus 2, okay, and here we have modulus. Then we have here v over x, we have x here equals then we have x here equals 10 meter, okay. To find v average over time interval from 0 to 3, then we have x over 3 equals 10 over 3 meter per second, okay. This is required. For point number 4, it's required to find v average vector over time interval from 0 to 3, then v average vector equals delta s over delta t. Then we have here this is equals, we have s here, or displacement, or x, negative 4t plus 2t square, okay, from 0 to 3, okay, over 3. Then we have here negative 12 plus 18, okay, this is negative 0 over 3. Then we have here 2 meter per second, and this is required to find. And it's clear that here v average is greater than v average vector, okay, as here v average we are using distance, okay, in calculation, and v average vector we using displacement, and we have also displacement is greater than or equal to the distance is greater than or equal to displacement all the times, and this required in point number 5. Now it's time to try to solve a problem. If downwards is a positive direction, a ball is thrown vertically upwards and returns back to the thrower 3 seconds later. Which velocity time graph represents the motion of the ball? You have to check these 4 graphs and select which one represents the motion of the ball. The answer is D, this one, but you have to find out why and solve it in detail.